Welcome back, fellow scrub. This is Smart D Wiz. We're working on the Retro Mansion game project today. It's Thursday, so that's the project of the day. And we'll just kind of jump right into it. Alright. So, what we ended up doing last time was reanimating the character into a animation that's not completely jank, and we ended up putting that just as an animation test. There's no actual platforming and collision at the moment, which we will be working on today. But it's just he moves left, he moves right, and because Tim tried to make a thing that didn't work right, but it looked like a kick, he can kick. He may not actually kick in the game, but it was funny, so we just put it in. Victory stream? Victory stream. Chat says victory stream. Is that because the Mario 2 ending song is playing? It's always a favorite of mine, Mario 2. I won't necessarily say it's like better than 3, but I think I like it better than 3. I get better good feels out of it. So, alright, we're gonna take this. Right now it's just, there's no collision, this is just an image. So it doesn't matter what's actually there. Now it's a prescription stream. Yeah. So all these placeholder images are ultimately irrelevant for what we're going to do. It was just kind of to not just have nothing here. So, it's better than just walking around that. And it also is a good way to see, like how does it look when he moves in the background and stuff. So these kind of little tests are important, in the long run anyway. So anyway. I guess we'll get right into the gritty. Let's see how far we can get in 2 hours. It shouldn't be too bad. So I'm gonna put in. I don't want to call it placeholder, but it is ultimately going to be placeholder code in some respects. Because there's a lot more to this, and there's only so much that we can get to for now. But I do want to enhance. Movement with options for like slopes and stuff. We're only going to focus on block movement, so like the first Mario didn't have slopes, and even second Mario didn't have slopes. Those kind of old games that are just the block movement, we're going to focus on that first, and then we'll eventually evolve it up. But this will be the first baby steps to that, so I'm going to just cut all that out. And so our player here does have a controller. That's cool. Alright, so what we're going to do is we're going to add a collision box. Which, I don't know if I can just add it here or not. Box Collider 2D. No? Spell Collider wrong? Probably. Box Collider 2D. Alright, so that gives you this green little box, and we're only really using this as a sort of, how do I want to put it? It's really just a template that we can use to easily edit in the editor, and we're not really going to be using Unity's collision system. You'll see what ends up happening. So, what do I want to do? This? No, that don't look right, does it? Oh, it's because his feet are down a pixel. I'm like, wait, why is it up? Yeah, so we offset his feet. And that's fine. That works okay. And then... Oh, I see. Alright. I think this is why normally I don't put them in the main object. They're just kind of a hassle to deal with. Yeah, and then you gotta divide that by 2. Yeah. Okay, you know what? It's gonna do what I would originally thought. I thought I could be a little more efficient there, but nuts to that. Alright. I'll call it the collision frame for now. Box Collider 2D. Okay, so here, this makes it much easier. Because then I can just, like say, if I do this, let's see, if I do 0.5 here, I think I can just scale this up, yeah, to whatever size that I want. And then you can do something like that, so. Okay, so that's the physical boundary of our character. You know, that's not supposed to go inside of any walls or anything like that. So, let's save. Let's see. Okay, this is a prefab, so I'm going to apply that. And then the next thing here... So we're going to have to actually code some stuff here. So here's a couple ground rules actually before we get to that. What we're going to be programming is basically little searches that go from the boundaries of this character, from the points, and they look forward and they're like, hey, did I bump into anything? And if I didn't, cool, then we just move forward. But if we did bump into something, we have to correct for that. And you have to make sure that your tile size for the, you know, what your well, actually this is a good one because it shows the grid initially. So your tiles, each one of these is a tile, and what you want to do is kind of figure out what's your minimum object size. How small can something get that's still collidable? And in this case we're going to use 16 by 16 pixels, which in Unity units is different, but we'll get to that. It's a little wonky. But visually, at least, we want to do 16 by 16. And we'll probably change that number as the project progresses to get maybe half tiles and slopes and stuff working. But at least for now, our minimum object size is going to be, you know, that. So if any part of here exceeds that size, which this definitely will, he'll be at least too tall. And we can already tell that by just dragging these over. How tall are you? So he's about 2. So he's going to have to check once from, you know, actually this would be a good place to demonstrate that. Let's draw it out. Hold on. And we'll get the grid in here just to keep things right. So he's going to check from the bottom of his foot and be like, hey, did I hit something? Then he's going to have to check midway to make sure that, you know, he's hitting the next one. Or well, probably what I'll do is I'll do it in halves here. So he'll check this far, he'll check this far here, and he'll check this far, and then this far. And then if anything is like, hey, did we hit something? Then we have to make sure that we align ourselves as close as we can to it. Well, transparency makes more sense. So it'll probably end up looking something like that. And then if there's nothing, you just keep walking by. That's just the basic idea of what we're looking at here. So to actually implement that, we have to do a little bit of code. And we're just going to do a basic system here. And then we'll expand it after. So, alright, we're gonna have a method that's update movement, and we'll do all our update movement stuff in there. Actually, a lot of this is probably gonna have to change too, because when we like get to a wall, we don't want them to be walking and all that stuff. So we do want this stuff here, though. So you know what I'm gonna do? Now we'll leave that. I'm gonna move this to its own method as well. And it's going to be called update inputs. And these are actually going to be all throughout the object now. So we change the scope of these values, and they can be accessed other places. Let's see. We're gonna move this into here. Because what we're gonna do is if they're both equal to something, we're gonna make them both equal to none. And that way we don't have to test for that all the time when we're doing something, so we can just assume that left and right are mutually exclusive, and then go from there. And so we'll do update inputs at the beginning of our update. And this is going to turn into a sprite only thing. So this stuff's kind of going to go on its own, I think. But we'll leave it alone for now because it's going to be highly dependent on how the movement itself gets shaped up. And, yeah, alright, let's see. So we do need an additional value here. I'm going to make a new header so we can organize. This is going to be... yeah, movement and collision. And we want a public box collider 2D. And we'll call it collision frame. And here, if we don't have the collision frame attached, then we don't want to do anything here. As we will, let's see, let's set an editor. So we just drag and drop what we want to be our collision here. Alright, now let's go back, make sure those changes are, Unity's happy with them. Put it that way. Looks like they are. So we are going to drag the box collider into there. Oh, and also we do need to change this. I believe we want to use it as a trigger. And used by effector. Is that new? I don't recognize that. Whether the collider is used by an attached effector or not, I don't know what that is. It might be new in this version. Used by composite. Likewise, I'm not sure what that one's about. Composite collider. Well, either way. Okay. We'll save that. Alright, let's see. What's the next thing we're gonna want to do? Oh, we need a jump button, too. Let me add that. Oh, you know what? These need to be moved, too. Down here. I'll make a new header inputs. And these will change wildly as the project goes. Let's see, jump key. As the project goes on, because we're gonna have to make like a whole controller interface and stuff. But these are just test controls for now. Okay. I'm just gonna start putting things in regions here, since we're getting a bit big blocks of code going on. So we can encapsulate that. Let's see, there was a kick key too, right? Yeah. End region. Yeah, there we go. Screw it. We'll integrate the kick with the rest of the stuff. There's no reason to really have it separated at this point. keep that. Keep that. Alright, we're gonna leave this stuff alone for now. Actually, let me just comment it out. It's not gonna be relevant right now, and if anything, it might actually cause a problem. So we'll take that out. Okay. Alright, so if it's pressing right. Wait, hold on, we need another value here. Private. And vector 2. Or we could just do vector 2.0, make sure it's what we're expecting. Let's see, we've got our walk speed here. So we're gonna basically be manipulating velocity here. And then that will be a negative walk speed. If we're pressing left. If we're not pressing anything, then we don't get any velocity on the X. And so we're gonna do jumping after. So we're first gonna do the movement as it is here. Okay. Then I'm gonna do collision checks, which might be its own method later, but we'll just flop it in here for now. So we want an integer of how many, we'll call it H count, so, V count, vertical count. How many, checks we need to do from starting from the bottom and going up. Where are we here? So we want like 1, 2, 3, 4, 5 probably. But we can do it. We can do it with a little bit more finesse. So we can say our public vector 2 minimum collision size. Let's say it's 1 for now. Oh, where'd that go? Wait, there we go. So our minimum collisions on the vertical count of collisions are going to be our minimum collider size. Oh, thank you. Deft right. Thank you for the follow. So we need to take the size of this on the right side or the left. It doesn't really matter. But we're just going to take in the height of this, and then we're going to divide it by the minimum size that we get. So let's see. We've got the collision frame. So it's probably have to use bounds and then height. Do we get height? Min, max. Probably have to use the max. Oh, size here. Size.y. Oh, I don't like it because it's a float. So we're gonna take the size and then divide it by let's see, our minimum collision size, which is y. Alright, well, I don't like it. Okay, we gotta cast it. And actually, let's make it a little debug section so we can see, make sure this is right. Okay, int. Yeah. vCount check. Public int vCount check. Say 0, but we're going to actually set it to what our result was, and we'll check that right now. Just make sure that math looks like it's right. Okay, is it happy? Yeah, alright. So this should, V, how did I capitalize it? Didn't like that. Oh. Could I give that second one a capital? I said it looks a little weird. Alright, let's let it compile. And, right? No? Oh. I didn't rename the other one. So it didn't like it. Alright, let's go. Okay. Okay. 2? Oh, because we got only one here. Let's say that ours is 0.8, so that should be 8 pixels, since we set up the sprites to be 10 pixels per unit. So a 1 would be 1.0 would be 10 pixels, so 0.5 would be 5 pixels, that kind of way. So you just displace it. Think of it as just displacing the decimal point there. So we want 8 pixels. We'll knock it. We'll say it goes up to half. So every 8 pixels is, you know, you want to do a check just to be safe. And then we'll see, what's our count get? Gets 3. It's probably not too far off as to how large this is. So it's 25 pixels. Yeah. Alright, I guess that works. That works. At least for now, it'll be okay. Okay, so now we need the distance. We're gonna kind of make them equidistant here. So we're gonna say we got 3 points. We've got the top, we've got the bottom, and we've got the middle. We need to figure out exactly where in the middle these things are. So the way to do that is to take our total height. Let's see. I'm gonna make a float because it's gonna have a decimal point. Let's see, v point distance. We'll say that. It's the total height of stuff divided by our count. I might have to add 1 to this. Let's see. Because then more, let's see, it's going to be whatever divided by 3. And so we're going to start, because, well, I'll show you what the mechanic here is. So int check is less than the count. Should be less than or equal to. No, I'm sorry, it's just less than. And v check equal, or plus. So we're going to be cycling through these, and we're going to say the distance from the bottom plus, you know, what check that we're on. Like I said, 0, check 0 is going to be at the bottom, so it's going to be 0 times the vertical displacement, which is just going to be right there on bottom. And then we'll have 1 times the vertical displacement, which should be somewhere around the middle. And then it'll do its check here. And then it'll be 2 times the vertical displacement, which will be the top. And so it'll be that. So let's see, yeah, the top has to be the full one. So I guess we'll see. I'm thinking, yeah, so it's gonna be 0, 1, and 2. So 2 times whatever our value is here should give us the full thing. So I think we have to actually minus 1 here on the count, because this is gonna be 3. You're going to divide this into thirds, but it's 3 points. So yeah, so you have to do minus 1. That's what that was coming in with. That's why I was thinking of modifying it by 1. So then for each one, we want to, well, we need a starting point too. So vector 2. Hold on. Let's say, yeah, vcheck origin is equal to transform.position. Like I say, it's a vector 3. It's probably going to want a vector 3 when I actually do the ray casting. And then, yeah, okay. So we're gonna check from the center. We're gonna change this eventually, but so that we only check from the sides. But just to get it up and going. This is how it goes. You evolve from one thing to the next. Okay, so we're checking from the middle, the bottom middle, which ends up being this. I don't know if you can actually see it or not. There's a very light little circle here, and that denotes the point in space that this is tied to. And it's the same thing as the player's origin. And we're going to go from there to kind of get our collision here. Oh, where am I? Moving stuff around. Here we go. Actually, to be honest, we should, just in case, use the origin point of this sub-object. So let me think. Maybe that's not a good idea. Let me think for a second. Because we will have to move this point. We are dealing in velocity. If we do have to hard call something from here, it may not match up with this. Yeah, I take that back. Well, for now, let's just use the player's thing like I originally had here. And use their route for this. Okay. So now, we have to actually do the checks. So we're checking... we're going to check the right side first. And we're going to test that and make sure that that works. And then we'll duplicate it to the left. Because we don't have any... Right now we don't have any facing values and all that. We already commented all that out. But we will eventually have to have something akin to that. So, let's see. Let me think for a second. So what we want... Checkpoint origin equals the check origin plus... Actually, no. I would have to do that. That's probably more work for it. So we want dot y, so we want the height. We want to add the vcheck times our viewpoint distance. So this is what I was saying when you have check number 0 here. It's saying how much do we need to add to this? Well, 0 times whatever it is going to be 0, so we're just checking down here. And then it's going to be 1 times whatever it is, which should end up around the middle, and then 2 times whatever it is should be the top. Since we have 3 points. Hey Deku! What's up? So that's what this code does. We're just giving it an offset. Check the check vcheck is the number of the check that we're doing. So like it starts at 0 here, and it goes up by 1 every time we go through this loop. So again, 0 is down here, 1 and 2, and it times is by that distance value. So we've got our origin, and now we need our, let's see, we need a minimum velocity. Hold on. You know what? Minimum check length is what I'm going to call it. And we're going to automatically generate this too. So the minimum check length, since we're starting from the center of the object here, is going to be the object's width divided by 2, so the radius to the outside. So, let's see. Collider frame dot bounds, bounds dot size divided by 2. Let's say 2f. Make sure it ends up being a float. So float check length is equal to our minimum check length dot x plus whatever our velocity happens to be dot x. So if we're adding to the velocity up here, it's going to be checking from here to here to see if we're inside of like a block and need to be pushed out. But it will also check a little bit further for how much we're moving. Alright, and this is a very old school way to do platforming, which here works out decent, but we will be, again, evolving it as we go along, because we will have other needs. I'd like, at this point, I think I'd like to include slopes and other things, but that will require a very extensive system to handle that kind of thing. So we're just going to start small, and we will add that stuff in over time. So, let me think here. We've got our check length. So now we want to actually do some ray casting, and just to make sure I got this right, let me cast 2D. Physics 2D ray cast. Okay, let's see. And then it all. We want raycast all. So yeah, because it could hit multiple things. Raycast will only give you back the first thing that it runs into, but you may not actually want to act on the first thing that you run into. Say maybe it's a different kind of object, like a thin platform or something that you can't necessarily walk into and be stopped by. Then you want to look past that and see, okay, was there anything behind it then in our path that gives us that? So, alright, this is what I'm looking at here. Raycast all. Yeah, okay. So var results, var just basically means, well, actually, it'd be better if I show it. Physics 2D raycast all. So whatever the result of this is, which is a raycast array, raycast hit 2D array, var just kind of says, oh, that's what you want me to be? Okay, that's what I'm going to be. It's an easy way to do it instead of having to type all that out. You be careful with that so you know exactly what you're dealing with, but, That's how it goes. Okay, so it wants the origin, so we do have the origin. Oh, they're all Victor 2s. Okay, that's fine. We can do that then. That's right, because it's 2D. I don't care about what the Z is. We want... well, the direction too, right? Yeah. Direction, distance, mask. We'll get into the mask after, but we'll do direction and distance. So direction will be transform.right, and the distance will be our check length. So actually, let me rename that then to check distance. Just keep it all the same. Okay, and then for these results, we have to go through them all. Let's see, it's a length, yeah. So another for loop to go through all the results. Let's say analyze results, so we know what we're doing here. Right now, we're not going to scrutinize. We're just going to take whatever we got. And, actually here, let me look at the notes. Make sure that they actually do return in the order of how far they are. Okay. Don't you like laser beam? Yeah, blah blah blah. The colliders in the array are sorted in the order of distance from the origin point. Okay, that's what I wanted to make sure. That way we search from 0 to whatever index in our array. And we just, if we find something we like, we can just end the search there. Because that's going to be the closest thing to us. And we don't have to worry about things beyond that, because we're not bumping into those. We're bumping into the thing in front of us. So, if there were no results, then this for loop will pass without anything happening to it. But if not, then let's see. We want our velocity.x to be shrunk by a certain amount here. So, because, alright, let me show this here. Result 0, or, well, just result ID, actually. You can get distance, and that will tell you how far the thing was that you collided with. So, we want to take our velocity, and we want to subtract, I think, let's see. Yeah, pretty sure we have to subtract, but we got to scale it back so we don't go into the object. So we want to subtract the amount of distance minus the minimum check length, because that's going to give you your border. And so I'll show you what that means here. So say this part on the inside here is his box. You're starting at the center of the box, and you're looking outward and say, I'm going to move, if the box wasn't here, I'd move all the way over here. Cool. But we did hit the box, so we need to know the distance here and scale that back, the velocity back to that. But then we want, yeah, actually I'm doing it wrong. No, I'm looking at it, it's a good thing I looked at it. Okay, because I was subtracting the distance from here, and I don't think that's right. We want to scale back the velocity to this, whatever the distance was. Oh yeah, I was doing it right there. No, I didn't say that. I did not. Okay. Whatever the distance is minus the minimum check length dot x. And that's our new velocity. That's how far we're going to move. Because yeah, say we wanted to go this far, we could only go this far. So we're saying that the movement can only go up to here, but we've got the border to contend with, so we gotta minus the distance from the center to the outside. And that should give us the amount of space we need to move. So yeah, that should be right. So the velocity is going to get overwritten to that. And then we can break out of that because we're done. We got the closest obstacle. We don't need to check the rest. And that's it. Closest. If I can spell here. Yeah, this is going to complain and be like, well, why'd you put a for loop if you're just going to end it immediately? That's because we haven't started filtering out. Because there could be stuff in here that we don't want to interact with, so... It's not an error, but it's kind of like, bro, what are you doing? You nuts? Why are you bothering having a for loop here? But that's fine, because we will be using it eventually. And then we do that check on every thing here. And then when we're done, we want to apply the velocity. So, transform that position. Let's see. Say new position. So new position plus equals velocity. And we send it right back to our thing. Why I don't like that? Oh, fine. There. Happy now? Vector 3. I love Mario 2. That's why there's a lot of it on here. Okay, and then we will draw lines to show. So let's see, debug, and we'll do if Unity editor that prevents this code from compiling on like release builds. So is it debug? Draw line, I think? Draw line. Or draw... Yeah, we'll do draw line. I think array might just keep going forever. That might work. How do we know what color it is? Or can we specify color? We can. Okay. Let's say red. Should pop out from our green dude a little bit. She could do yellow too. Nah, I'll do red. That's fine. Alright, well, let's see if this cobbled together mess actually works. We should be able to see something even if we're not moving, because we are checking from the distance, or from the middle out to the outside. So let's see. Let's see what we get here. Uh-oh! What? Oh, what is he doing? He's just like, I'm out of here. See you later. Oh, okay. Well, the line is not in the right place, so that's part of the problem, I guess. But it didn't hit anything, so... Alright, hold on. We'll figure this out. What's our velocity? Should be still 0. No, our velocity is actually something. Why is our velocity something? Alright, there's something wonky. Hold on. Okay. If is pressing right is true. I think we're pressing left, maybe? Something's up here, something's up. I think we also have to clean it out here too. Yeah, let's also take an old velocity. Old velocity equals velocity, and then velocity. Okay, let's look at our input code now. It's pressing left, it's pressing right. Both faults originally, we're looking to get the keys. And if they're both pressed, then set them to none. It is getting updated here. And then we do go straight to update movement. Okay. Let's take a look again. I didn't really change much here. I don't think cleaning out the velocity should matter much, but we'll see. For some reason thinks the velocity is that. Alright, let's take a look. Do you think we're pressing something? Oop. Faults and faults. So by the time we get here, the velocity is 0. Alright, let's go down to here. Think we're actually getting something? Oh, you... Yeah, alright, I know exactly what's going on. I forgot about this. You yourself are also a collider. And you do detect yourself. I forgot. You have to make sure that your collider is not you. So, is it you? Yeah, alright. That would make sense. You're literally colliding with yourself and getting pushed away. So collider is not equal to collision frame. It should be analogous. Okay. It's you. Ignore yourself. Okay, that's it. It's you. Yeah. It's you. Okay, yeah. If you're colliding with yourself, just ignore it. Alright. So there's one case where you want to just continue on and look for the next thing. So there we go. Alright, we shouldn't be moving anymore. We're still doing it! Oh my god, why? Why? Oh no. Let's see. Oh wait, hold on. I'm sorry, I think I did this backwards. So collider is... Yeah. I did it backwards. Okay. Now it should work. There we go. Okay. Cool. And we see our red lines here are exactly where we need them. They're at the top, the middle, and the bottom. And so, you'll see they're searching from the center here out to the right. But we don't have anything else to actually bump into yet. So that was what we're going to do next. And also, I want to put a failsafe in here. So if the V count is less than 2, then the V count's gotta be 2. That prevents the distance from dividing by 0 and shit like that. Because you want to divide by at least 1, so 2 divided by 1 or 2 minus 1 is 1, and so this divided by 1 is going to be just itself. So if value goes any lower, then you could hit a divide by 0, and that's bad news bears, and you don't want that, because it will be very, very upset with you. Alright, so let's see if our actual code works when colliding with something. Test collider. Let's see. Create a new folder. Just test whatever. It's fine. Just need to make a material so we can view it. It actually has some visual to it. Test collider solid. Put a capital T of Venus. Unlit color. I don't know. Red? No, that's already our thing. We'll do yellow. Let's bring this out here, so I can see all the stuff at once. Actually, yeah, let's reverse them. Okay, so our test collider is going to be box collider 2D, just like our character. And we're going to drag... Oh, wait, hold on. Crap. Mesh filter, we gotta give it a visual component here. Quad. Mesh renderer. And now we can add that. Okay, so now we've got a visual. And there it is. So theoretically, we should not be able to move into the box. If something messes up, we'll fix it. Hey, look at that! Can't move in the box. Programming, everybody. Programming. Alright, that's it. Ship it. We got can't pass the box on the right of the game. We're done. We've got it. We're done, everybody. We've got it. We're good. It's video games. Alright, that's cool. But if we... Well, just to show you what happens if he's on the right, it's not going to end well. He's going to get zipped through. Because he's only checking... he's only checking that one side. So as soon as you get too close, boom. And it's because it detects it as a right wall when it's on your right side. Once you move far enough into it. Let's make another one and put that there. So now we've got both sides to test with. Yay! And you can see it here. I gotta drag this out. You can see it here. The lines won't let you go inside. You see it trying to on the bottom. See, it's trying to move this far in. It's moving 2 pixels in, but it won't let it, and it corrects it. You see the other ones don't go farther. Alright, might have actually have an issue here now that I think about it. The new check distance. Let's see. So if this result didn't do anything, yeah, we need to do the new check distance as the return distance. Because we already know at this point, once we bumped into something, we're like, okay, cool. We don't need to check. We don't need to check further. Because say, just for the sake of argument, something like this happens. They were checking out here. I was like, oh, we bumped in over here. Cool. Alright, so we're gonna move dude up here. And then we go over here and we're like, okay, let's check the top, and we're like, oh hey, we found a thing. Because we're checking all the way over here still. And cool, so we're gonna move him. We're gonna move him up here. Like, oh wait, hold on. No, that's not good, because now we're inside the block. So basically it says, you know, once we get moved up to here, that we're only gonna check well, he doesn't actually move up there yet, but once we hit this, we're only gonna check up to here again. So let me set this up again. It's gonna check in here, and they're like, oh crap, okay, this is where, as far as we're going right here. And then when it gets up here, it's only gonna check up to here again, because we've already established that this is we've hit something here. So the only thing we need to respond to would be something that was even closer. And then we can only move up to this point. So that's why I had to make that change. And we can test to see if that's working. We'll just do this. Excuse me. And see if he goes. Yeah, I think it's working right. Yeah, because he wants to go farther over here, but he can't. Because it checks here, which readjusts it, and then it checks here and says, oh hey, yeah, that's closer. Cool. And so the reverse also has to be true here. Yeah, and he's only stopping at here, so he's not getting adjusted to the second part. And we can prove that by aligning them further, and boop, see, he gets to move in. So, alright, we're all good on that front. That glitch has been avoided. Cool. Working out good so far. And then you can also test, make sure, like, if he bumps his head, he ain't going through. And yeah. So he has to clear entirely to get through. And same thing with the bottom. He can't walk. Yeah. Perfect. Alright. I'm liking it. Is it the McDonald's slogan? I'm loving it. The McDonald's can go to hell. They're terrible. Maybe if they actually decided to serve something even close to resembling food, I wouldn't feel that way. But, they don't give a shit. They wanna effectively sell you crap, poison, and shit. No thanks. Okay, so we need to now replicate this on the other side, because again, he's just gonna go flying through this wall. He thinks he's colliding on the right. Okay, let's see. That's the V check. Alright, we're gonna have to make some of these values, pull some of these values out here. Same thing with check distance. I'm gonna have to come out here. Because we have to basically copy this code. Hey, McKids. Say what you will about the game, but I liked it. And the music. Alright, that can stay there. Okay, that's good. recheck right. And then we're going to copy it. And recheck left. And so the direction is now just going to be negative right, which will be left. And okay, so this here is going to have to be a negative distance to draw the debug line correctly. And we're going to say this one's yellow. Or green. No, not green. Blue? Blue. Because our boxes are yellow. See, McDonald's gave you something. The only thing McDonald's gives me is a very painful night on the toilet. But McKids is okay. It's alright. Let's see. I think this is okay. I think we're okay with this. It should all just be pointing the other way now. But our distance is not, we don't need directionality there because we've got directionality here. And then we check the results and we modify the distance, which again has no directionality. I guess this should be okay. There's some things here that you could run into edge cases, but it should be okay in the way that it is. Like, if you get squished between two things, it might get a little crazy. But I think it should be alright here. Nope! No, it didn't. It didn't. No. Did not go. Nope. Okay, I think what I need to do here is to reset these values first. Well, I guess they get set anyway. Alright, well, hold on now. Alright, let's see. What do we get? Do we get lines going left? We get blue lines going left. Okay. That doesn't seem to care. It's modifying this, so... I think it's because it's a negative velocity. It needs to be impacted negatively. Sort of? And we can't leave. We can't get away from it. Alright, hold on. I'm messing something up here. It should be negative, though. Oh, man. Okay, let me put in a couple safety nets here. If the velocity is a certain value, then you kind of just don't have to worry about it. Like, if velocity is not greater than 0, then we're not going right anyway, so it doesn't matter. This also can cause some problems, so we'll come back to fix that later. Then velocity x. is less than 0, so going to the left. Then we have to check to the left. I mean, it looks like this is okay. Should be checking to the left, and it looks like it is. When we get the results, if it's us, we ignore it. Then we adjust the velocity x. So the distance is going to be a positive number minus the minimum check length, which is also a positive number. So this is relative. It should just be negative then, because your velocity is already negative. And the check distance should be check distance, because that's, again, relative. Maybe? I don't know. Let's see what it's doing again. Alright, well, we're not trapped anymore, at least. Let's see. Let's put a little check here and see what we get. Oh, sorry, put it here. So only check if it's negative velocity. Wow, that didn't go too well. What the hell happened? I didn't like that. Holy shit. Excuse me? Excuse me? Whoa. Whoa, I did not like that. What the hell happened? I did not, you know what, hold on. Before anything blows up, let's save. Close Visual Studio. Yeah, I want to stop debugging because you went nuts. Let's try that again. These tools aren't perfect. Sometimes they get a little weird. Okay, so let's put it at a different point just in case. Right. And play. Oh, right. Yeah, it's just gonna catch every time there's negative. So let me get to the wall first. Now we'll turn it on. And now, left. Okay. Our velocity is 0.2. 3, 4, 5, 8, 4, 1, blah, blah, blah. Okay, so we're actually going to check to the left. Let's get down here. Our origin looks okay. Our distance is the velocity, yeah, plus the additional length here. So, minimum check length, there we are, 0.5. And so our distance is 0.26. Yeah, good. Okay, I see the problem. You need the absolute value of this thing. Because the distance, again, is relative. So that was the mistake, because this was a negative number. It was actually decreasing the length here. So that wasn't right. And so when it tried to get the distance, tools are made to be broken. When it tried to get the distance, yeah, here. So we're good. It was getting an incorrect distance value. And so you only see the red and the blue now when when you're moving because we put in those little velocity indicators. But that also means now that if we move this into here, he's not going to react until he starts to try to move. So now that we've fixed this, let's see if we can maybe back off on this part. And see if that will work better now. Oh, and he's stuck. Okay. Alright, there is a way to fix this. Trying to think, how do I want to fix this? There's a couple different ways to do it. One way is to make the check not always check all the way to the end when you're not moving, so the minimum check distance is actually back a little bit, plus the velocity of what you want to move. It's the usual way to do it. I'm trying to think if there's any less complicated way to put in just for now. Or if we just put the we'll just put the conditions back. I'm not expecting to have any moving solid objects at this point, so we'll do that after. Okay. Now we gotta get into the, let's just uncomment all this. We gotta get into the visuals now so that he starts walking and stuff again. We're gonna call that is right facing right because we now have potential confusion with the name of that. Is walking. Hold on, is kicking here. We gotta put this up front. Because we don't want to walk if we're kicking. We're gonna say if we're not kicking is the only time we can move. So that when the kick animation starts, we won't be moving left or right anymore. So we do have to check the kicking first. Let's see. So is walking. We check that here, whether they're pressing left or right. Oh, we gotta get rid of these, the walking speed things. That's old stuff. We don't need that anymore. The rest of this might be decent, but I want to make a couple important distinctions, but let's get it actually working first. Pressing left. Yeah, okay. So instead of this press left and right, we could try to say if the velocity is greater than 0 at the point that, because when we do the correction, this could get turned, possibly, the velocity could be turned back to 0, because it, you can't move left or right from your position. And in that way, he'd stop at the wall. So let's actually make a tag for this. Public bool stop run animation at wall. We can test both of them, just so you see the difference. So, if that, and then if not, else, we're going to do what we did before. But in here, walking is equal to whether or not velocity.x is equal to 0, or not equal to 0. And I like to put these in parentheses. You don't have to. It kind of makes me cool me into that I'm doing a Boolean thing. That's just weird old me. So if there's no actual movement, then we're not walking. And if we're walking, we're walking. And if we're not walking, we're not walking. So let's make sure any of this works first. Hey, there we go. And that is not good. That's not good. I don't know why. I don't know why it's all bugged out again. What the hell happened? Did I undo something? No? Oh, come on. What happened now? I'm not adding anything anywhere else, am I? Oh, the other thing we have to test is whether or not we're still moving. Okay, I'll put this back over here. Can we move and kick at the same time? Okay. Well, other than our animation being wonky. No, we cannot. Okay. That's good at least. But this got weird again. What the heck happened? Yeah, and Spider-Man's voice from Marvel's Capcom. What happened? I can't do it, so I'm not gonna bother trying, but... What the heck? Alright. I'm gonna bring this back down here. What happened? I can't check without doing it. It's getting all wigged out for some reason. It's only it's correcting randomly. Alright, that's really weird. What did I change? What did I change? Did I change anything? Here? Alright, this is getting all weird now. All I changed was this stuff. Oh, maybe the facing left or right got screwed something up? Oh, yeah, that's what screwed it up. That's what screwed it up. Oh, we're changing the rotation of the object, which we don't want to do now. We want to do that to the sprite object. Sprite anchor. That's why. Okay. That would explain it. Yep, we're happy now. Okay, so that's what we got. Okay, so the other switch that we made here is to stop the animation at the wall, and that's what this does. So we can say, do they stop? Because I'm still holding, still trying to walk into the wall, whether or not they stop or not. So that's how that works. I'm not sure. I kind of don't know what I like more. I'll keep it on for now. But yeah, in the long run, I'm not really sure. Okay, now, what about under him? This gets a little trickier. We're gonna start pulling this stuff out into its own thing. This one's gonna be private void check horizontal collisions. Keep that clean. Check vertical collisions. So here we want to check the ceiling first and then the floor. And we're going to do this similar structures here. This is going to be H count, so horizontal count, because we are checking from the top, from the left to the right. So the size dot x divided by the minimum collision size dot x cannot be less than 2, same as before. Hold on. What is this? Deep check count? Oh, this is the debug. Yeah. So we want an H check count. Make sure we're getting the right thing here. I'm gonna write debug next to it so we know what that is. H point distance, so the collision x divided by the H count minus 1. H check origin is actually going to be this minus the size divided by 2. Oh shit. 2F. Oh, sorry. Oh, hold on. Okay. I have to do it on the next line. Dot x minus equals the size. So the reason we do that is because the center is actually right here. We don't want to start checking here and then moving to the right. We want to start checking here and moving to the right. Well, guess what? The size, the width here, divided by 2, subtract it from the center, we get over here, obviously. So we want to start from the left and make our way to the right. And that's all this is about. So we're taking the size and, you know, shifting it to the left there for our origin. Okay, so the minimum check length is going to be that. Actually, this can just be a thing that happens before that, can't it? Then we don't need it here. And yeah, no, I think I already took it out of here. Yeah, okay. But that's gonna be the same no matter what. And since we're calculating both X and Y here, we might as well just make it that. So check vertical collisions as well. Okay. And we also need we need a fall speed. This is not going to look pretty, but it'll be something we'll get for now. I'm not going to call it gravity because that's going to be calculated differently. We'll get to that one a different time because we're getting close to the end here. But time, delta time. So we're constantly falling all the time. And fall speed's going to be negative. Regardless if we're kicking or not, we're going to keep falling and falling and falling. And since... let me just... no, actually there's nothing gets calculated there. So, I can show you, since we have now falling in there, what that looks like. I have to zoom out because you're just going to start falling immediately. Alright, ready, and... and he's not doing it. I think I know why, though. No? That should be okay. How come he's not doing it? Do he still move? Yeah, he's still moving. Hold on now. Alright, what's up with this? Because we're adding velocity to the position. Oh, I'm sorry. I'm dumb. So we added a false speed, but we didn't actually give it anything. So let's say it's 14 like the other one. That's why it didn't fall, because it was false speed was 0. There we go. So away he goes. Bye-bye. And obviously we'll change that value to make sure that, you know, he's got a nice little jump arc and stuff, but that'll come later. Okay, so now he's falling. That's fine. So we need to correct for it because there's no correction now. Okay, so check origin. Check once. Okay, we're just gonna copy this and put it in here. Now some of the names changed, so we're just gonna have to change a few of those. Let's see, H count, H distance, H origin. Oh. Okay, so the direction to be transformed to up. Oh, we also need No, that should be okay, right? No, it's not. It's not okay. We have to, just like we offset the left and right, because we started at the center, we had to go to the left, and then we can search up. Well, we're actually starting on the bottom here. So we move left, but we need to move up halfway to start looking above. So there's something's coming down, we can, like if we jumped into a ceiling and the ceiling's inside of us, then we can push ourselves out. So this Y needs to... God, you know what? Just... Here. No, that's... I have the positive Y. Never mind. I was gonna say we could just add this division here, but if we just, instead of dividing just the X, we could do the Y, but that's not gonna work either. We have to add, what we should do is add that. So we have to add a positive Y and add the negative X to get what we want. In Unity, and this varies depending on the environment and how you code it, but in Unity, up is positive, and a lot of the old systems, up would be a negative thing. So if you thought of like the top of the screen here as being the origin for your grid, and then going down in Y, or going up in Y, would make you go down, and going down in Y would make you go up because the origin's up here. A lot of the old games worked off of that, and then X right is positive and X left is negative. But here, going down was actually a positive Y. A lot of engines work that way. Unity doesn't do that. They flip it. So sometimes I get confused because I'm used to working with the down is positive, but we have to actually add here to go upwards to reach from the bottom here to the center, so that we can do our checks from the center. Okay. Point's gonna be the origin plus. Alright, this is gonna be H check up. It's gonna be Y. Check distance can be Y. Minimum check Y plus velocity Y. Point distance. It's gonna be Y. See, most of these X's gotta change to Y here. I think. No. Right? No, point distance has gotta be X because we're checking left to right. But the distance is gonna be vertical. So our minimum check from the center Y plus the velocity Y. And then so this is if Y is greater than 0. Transform that up, check distance. Okay, so here these are going to be reversed. For our debug, because we're using Y now. So the origin plus, or origin, then starting at the origin, then the origin plus our distance. So that's fine. So we get our results, and the Y value is going to change here, not the X, and our distance is going to change, and that should be okay for that. And so now we're going to the only thing that changes here is think this, and the absolute value. So I'm just going to copy it from here then. And this is checked down now. There is no down, but there is a negative up. So we'll do that. The negative on that. And this has to be absolute value of y. Let's see. Just looking it over. How did this change? Did this change from here? It did not. Oh, but the outside did, so it's now negative. Yeah, that makes sense. We're going down. This might work. And this one's gonna be less than. We'll find out. Okay, so we've got to copy and paste one of these and put him down here. And what do we get? Okay, it's not terrible. Whoa, well, he's going a little fast. Huh. Something's not right here. Let's pause it and then we'll step through. Oh, you know what? Let me change the color here from red to blue. Then we can at least see the progression here. There is already a problem, and I think it is the H distance. How does this get applied? Yeah, it's got to be on the X. That's part of it. That's a part of it. Okay, it's not quite right. Okay. It is going down too far. Because, like, it's still checking in. Let's put the focus on here and see what's going on more specifically. Looks like it's checking farther than it... No, it's checking okay. But the... Oh, okay. Okay, I see what's going on. The left and the right are detecting the floor, because they're right on it. So what I need to do is to move everything in just a little bit. And also, yeah, I'm not sure what's going on with the ray casting being... Let's do a test here. Yeah, that is where the ray is. Yeah. Huh. I was wondering if these debug outputs were actually correct here, but they are. So So that means that the offset is wrong here. And that's because I used an X instead of a Y. That should be better now. There, maybe? Yeah, it looks like they're okay. And yeah, so if I try to move right or left, it's gonna get all wigged out because it's detecting the floor, and that's bad news bears. So let's see. How are we gonna fix this? Well, what I could do for the horizontal collision, we could say recheck origin dot y plus equals 0.1, so it goes up 1, and then the point distance I'll say for ceiling correction. Point distance is going to be minus equals 0.2. That might help. Then they should be like 1 off the ground. Let's see if that does anything. There we go. So when they're, yeah. No, I can't really pause it there. Oop. Let me knock down his walk speed and it'll be easier to see here. So you see that they're 1 pixel above the ground, so they're not connecting with the ground and messing everything up. There's more solid ways to handle that, but given that I've only got like 10 minutes left, that's what it's gonna be. And so, here we go. Whoa! Well, that ain't good. That ain't good. So we'll have to do that with the vertical. So in this case, the check origin is going to be plus 0.1f, and the check distance, point distance is going to be minus 0.2, just like the other one. And that should kind of enclose it in a little. I think the left one didn't freak out only because of floating point rounding. Yeah, there we go. Look at that. Look at that. We'll have a level yet. Alright, player's gonna get moved up a bit. And just gonna come up with a little, not necessarily a level layout, but you know what I mean, just a little testing ground here. There he goes. How about that? He's a moving and a grooving. Alright, and turn his walk speed down a little bit. Let's do 12. How does that look? He's still a little fast. 10's a little more manageable. We'll do that. Yeah. There we go. How's that? I think it's getting a little... It's bugging out a little bit. Huh. Like velocity is a little off there. Well, we can fix that later. Quick fix is just not to have the animation thing going. There. And we can test. Conditions like this. What? Why are you not? Oh, there we go. There. And on the right side, we can check those. Cool. So how about that? Ain't that something? There you go. He falls, he runs, doing all the good stuff. Alright, let's make a janky jump. It's gonna be an infinite moon jump, but it's gonna be something special. Oh, we do have a jump key already. Okay. And we'll just jump key. We'll put that down on the bottom. It's kind of its own thing. Oh yeah, where's jump or kick getting checked? It's over here. Nah, we'll keep it. We'll keep it where it is. It's fine. So here, I guess it would just be plus. Well, we'll make a jump speed. We'll actually do that. There's fall speed and jump speed. Jump speed. And we don't need those brackets. Alright, this is super jank, but as long as you're holding the button, he's gonna jump. And he's gonna keep moon jumping forever. Oh, and then we can, because of that, we can test ceiling stuff. Player, controller, inputs. Okay, so jump. I'm gonna make that L. Okay, that's a kick. And jump don't do nothing, because we don't have a jump speed. There we go! And we can't jump into ceilings. How about that? Look at that. Ceiling code works. Look at that. Game Genie codes. Yeah, really. Woohoo! Out of bounds, baby. Good. It doesn't look like it's screwing up at all, so I'm happy with that. Game Genie. Pretty much. You know what we probably could put in quick is the jump animation. Let me see if I can add that quick, and then we'll go out on that. I'm pretty sure it's already animated in here. But we'll find out in a second. Yeah, we gotta jump. Okay, so we have to check if the velocity, yeah, so bool is jumping equals the velocity dot y is greater than 0. So if we're not kicking and we're not jumping, do that. So then, if we are jumping, then we just want to play animation. Actually, we're going to do this as not equal to 0. And we'll rename it is jumping or falling, because we want that pose if we're jumping or falling. Jump animation name. Might be as simple as that. We'll see. Yep, there we go. Yeah, so let me bring everything in just a bit. Since we've got jumping now. Now we can kind of hopefully fit this all on one screen here. And we can fly around with ease. Oh, bringing the camera with it, that ain't working. Hold on. You know what? Make a solids object here, and then I can move it around. Then we can play it on here. Uh-oh. Something went wrong. Didn't like that. What the hell happened? Did he get stuck? Maybe he got stuck because he was on the corner. It could be a glitch, but let's just move him over a little to fix that. Here, you go over here. There we are. Yeah, I think he just got caught in the corner. There we go. Oh! Uh-oh. Uh-oh. Got stuck. I think he got stuck. What the hell happened? Huh. Oh! Because his jump speed's not anything. I didn't set it permanently. There we go. Oh no, you can't turn in air. That really does look like a Game Genie code. Well, we don't like that. Apparently he thinks he's... Oh, cause... Oh, okay, yeah, cause he's, He doesn't necessarily have vertical movement. He doesn't have any vertical velocity, so he just thinks he should be walking. That's funny. Well, it's a work in progress. Oh. Yeah, so he don't like edges. We'll have to fix that. He might get stuck again. No? There. I'm getting stuck on the edge. Huh. Well, we'll fix all that in time. Yeah, you don't like that. Oh, he's getting all weird now. Oh well. Yeah, that's funny. Alright, yeah, there it is. There's some collision. It's basic. Balanced. Only one little tiny thing I want to change here is, if he's jumping, then I want him to be able to turn around. But that's it. That'll be the last thing. Yeah, there we go. There. Yeah, it's more like actual doing a thing. I don't know what's up with this one. It's getting all weird. Okay. But yeah, there you go. So there's the basic collision. It only works on boxes, but you know, that's what the NES had anyway for a lot of games. Of course, we want to try to go a little bit farther with it, but for now, this will get us started. So, how about that? And it is just 9 o'clock, so we're good. Thanks everybody for showing up. This stream, Game Dev Scrubs, is sponsored by our patrons. So, let's see. We have super top tier patrons that we do read the names out of, and so we've got Zombie Killer, so super ultra top patron. I've got Jerry Berry, Javier Garcia, AJ, Bryce Nagoinum. And so thank you super extra much for your insane support throughout this period. And so if you too want to become a patron, we got some code samples and other stuff as rewards, and you can check that out, link down below. And then we got a Discord if you want to see throughout the week updates for any of the projects and the discussions that take place, you know, for design and all that. That's where we do that. You can follow me on Twitter. I post stuff there for all the projects, and that's pretty much it. So I'm gonna get out of here, scrub out, and have a good one. Good night.